Hello guys, if you remember, the timer instructions were explained in the previous video briefly. In this video, I'll show you a simple industrial circuit using ISPSoft software, and then I'll simulate its logic using the PLC Sim Simulator. Also, I'll review how a program can be loaded and tested with my S7-300 PLC. After that, I'll show you how the force table option can be used instead of the push buttons which are connected to my PLC inputs. In the next video, I'll do a more practical project with Factory IO to learn the timer instructions.
Before we get started with today's video, I just wanted to inform you about all the great content we have been releasing on the PLC Goods YouTube channel, which includes industrial automation PLC programming, HMI, and microcontroller-based developments. My name is Syed Reza, and if you enjoy this video, I would appreciate it if you could click the subscribe button as well as the notification bell, to receive the latest and the greatest content I will be posting through the channel.
Okay, let's start the video. If you remember from the previous video, this industrial circuit starts a motor for 5 seconds, and after that uses the second motor instead of the first one. Let me test it again. Now let's see how the logic of this control circuit can be implemented by my S7-300 PLC station. That's simple. I need two digital inputs to start and stop the motors, and two digital outputs to control the two motors. As you saw, the first motor is turned on by the start push button, and also can be stopped by the stop push button. So let's use SR instruction to turn on or off the first digital output related to the first motor. Also, when the second motor is turned on after 5 seconds, the first motor should be stopped. So let's use a normally open contact of the second digital output to turn off the first digital output. Okay, this simple program controls the first motor. Now let's use an on-delay timer inside the second network. It must start its work when the first motor is turned on. Okay, this bit of memory is enabled after 5 seconds. Again, let's use ASR instruction to turn on the second digital output. In other words, the second motor with this bit of memory. Note that I had a mistake in my program. I used M0.0 inside the first network for another purpose. So I should use another piece of my PLC memory to restore the status of the undelayed timer. For example, let me use M0.1. Okay, also I need to use the second digital input to stop the second motor and also reset the timer, not the first digital input. Now let's test the program using the PLC SIEMENS simulator. Okay, my program is working correctly. Now let's test it using my real PLC station. Note that based on the wiring of my PLC station, I only replace these two digital inputs with the next two digital inputs, which are connected to these normally open push buttons. As you know, the first step is closing all virtual CPUs. Otherwise, Simatic Manager won't find my real PLC station. Now, let's select the configured PLC station in Simatic Manager to transfer the whole project. Remember, I've connected my CPU module to my computer using its MPI port. So I need to select one of these two interfaces, PC adapter, either its auto or MPI choices. Also, I can use the accessible nodes icon to check out which PLCs are connected to my computer. As you see, only one CPU is connected to my computer directly using its MPI port. In the previous videos, I told you how to use the microswitch on the CPU to reset it. As you see, I can also use my Simatic Manager software to reset my PLC. Okay, let's continue the video. As you can see, my PLC has only a system data and some system function blocks and system functions. System function blocks or SFBs are part of the operating system and are not loaded as part of the program. And system functions or SFCs are programmed functions that are integrated on the S7 CPU. However, because I reset my CPU, I can't find the main block OP1 or any functions and function blocks as the user program. Now let's transfer my project to my PLC, which includes only one organization block, OB1. Okay, I loaded my project successfully. Let's open my CPU again. As you see, the main block OB1 is added here. Now let's test the program using my PLC station. Okay, now let me tell you an important and useful point. Suppose my push buttons are broken or a problem has occurred in the wiring, and at the same time I need to start or stop the motors immediately. I don't have any time to repair the push buttons or check the wiring. In these conditions, the display force values item under the PLC menu is a simple way to solve the problem immediately. Now let's select the two digital input addresses which have been used in my program. Inside the force value column, I can determine my desired values for each input. So let me use the force table to test the program instead of using these two push buttons. Well, I can use these two items to enable or disable the force values for each input. Note that when a force value is used for any input, my CPU turns on its force LED. Another important point is that when we use the force table for some inputs, then the real state of the selected inputs won't have any effects during the program execution. Now let's disable the force mode and test the performance of the PLC inputs. Thanks so much for watching this video. In the next video, I'll do a more practical project with Factory IO. I'll see you soon. Bye.
Thanks for watching my content. If you have any question on this topic, make sure you leave them in the comment section below, and if you can spend a few seconds of your time liking as well as sharing this video, if you enjoyed it, that will mean a lot to me. If you have any suggestions for the channel, such as what kind of hardware or software I should be covering, then make sure to leave that in the comment section. See you next time. Bye bye.